class. In today's video, we're going to be going over the solutions for the practice cat. So for part A, the first question wants you to graph y is equal to 2x minus 8, and you need to find both the x and y intercepts. So finding the y-intercept is quite easy. So the y-intercept is always going to be the value of c. So in this case, it's going to be equal to -8. So I've written the y-intercept in the form of a coordinates. To find out your x-intercepts, we simply sub y is equal to 0. You do that, rearrange to solve for x, so move 8 to the other side. So I'm going to add 8 to both sides of my equation, divide both sides by 2, hence x is equal to 4. And once I've found out my x and y intercepts, remember to find out, or to draw a straight line, all you really need to know is two coordinates and draw a line in between those two coordinates. So in this case over here, I've drawn my straight line, and I've also stated my actual coordinates. And make sure that you are expressing the coordinates in your final answer when you're actually sketching this as well. So for the next question over here, this asks you to sketch the graph of y is equal to 5x minus 10. So we do the exact same thing. Your y-intercept is going to be equal to -10. Your x-intercept is found by subbing y is equal to 0. We're going to add 10 to both sides, divide both sides by 5. Hence your x-intercept is going to equal to 2. So therefore, when I'm sketching it, this is what your graph should look like. And I've also included the coordinates over here as well. For this question, sketch y is equal to 3x plus 9. Your y-intercept is going to be equal to +9. Your x-intercept is going to be equal to -3 in this case. And I've also drawn it like here. So hopefully you guys have got this as your answer. And for the last question for part A, y is equal to 2x plus 5. Find the y-intercept, which is going to equal to 5 in this case over here. Sub y is equal to 0 to solve for x. Move the 5 to the other side by subtracting both sides by 5. And then lastly, divide both sides by 2, and you should get -2.5 as your answer. And therefore, when you're graphing it, then this is what you should have gotten. Let's now move on to part B of the cat, and the part B is probably the most trickiest part, okay? So the part B reads, a cat is sitting quietly, watching a butterfly sip nectar from a colorful daisy in the grass. The butterfly is disturbed and starts to fly. The cat starts to chase. As soon as the butterfly takes off, the butterfly travels in a linear path given by the equation y is equal to 0.8x, where y represents the height above the ground in meters, whereas x represents the horizontal distance from where it took flight in meters. Assume the cat starts next to the butterfly and runs for a certain distance before jumping in a straight line given by the equation y is equal to 4x minus 6.4 to catch the butterfly. Alright, now the first thing I want to quickly emphasize is that obviously this over here is your equation for the butterfly. This over here is your equation for the actual cat, but I really want to stress out what the variables actually represent, okay? So over here, I'm saying that the y over here is the height above the ground and x is the horizontal distance. Now, the very first question of part B wants us to sketch both of these equations on the exact same set of axes. And you can do this in one of the following ways. You can draw your two equations on this particular Cartesian plane over here, where you show both the negative as well as the positive values for both x and y. Or alternatively, you could draw both of your straight lines on this particular Cartesian plane. If you guys recall from our previous lessons together, I've stated that when you're dealing with application questions generally, most of the time, there isn't really a negative value at all for most variables. So in this case, your variables for y represents the height above the ground. You can't really have a negative height at all. And similarly, you can't really have a negative distance. Distance is a scalar quantity. You can't have a negative distance. You can have negative displacement, but in this case, it specifically was referring to distance over here, okay? And because you can't have negative height or a negative distance, then for the purposes of this particular cat over here, I'm going to be drawing my graphs on this particular Cartesian plane. You can do it on the first method if you like, but because you can't really make much interpretations, I suppose with this one, that's why I'm opting for the second one, okay? So I'm going to be using this particular Cartesian plane over here. So for the first question over here, I'm going to be graphing y is equal to 0.8x, which is the equation which describes the motion of the actual butterfly itself. So in this case over here, guys, because it says y represents the height above the ground and x represents the distance from where it took off flight, that means that in this case over here, your butterfly is going to start at 0, 0, which is the origin in this case. So at the point 0, 0, the butterfly is still going to be on the ground, but obviously it then moves on and flies up, okay? So in this case over here, in order for us to graph it, we need to actually find both the x and y intercepts. So let's just find out the y intercept first. So we'll sub x equals 0. If you do this, you'll notice that your y intercept is going to equal 0. Sub y is equal to 0 to find out your x intercept. If you do that, then notice that your x intercept is also 0. Generally speaking, I told you guys previously that you need to know two coordinates to draw a straight line and then plot a line that goes right between those two coordinates. But in this case over here, notice that your x and y intercepts are the same, so you're not going to be able to draw a straight line using this particular method. So instead of actually finding both the x and y intercepts to actually graph y is equal to 0.8x, instead what I recommend you to do is use the table of values. And this is something that you should have previously learnt back in year 8 and year 9 when you first learnt about substitution, just inserting numbers into equation. So in this case over here, I'm going to substitute values starting from x is equal to 0 all the way to x is equal to 4. Do you need to include this much? No, not necessarily, but obviously having more points, it means your numbers are going to be a lot more accurate. So, but minimum is always going to be 2 coordinates, okay? So what we do is we're going to substitute the values in. I previously found out what the y value is by subbing x is equal to 0. So let's sub in x is equal to 1. If you do that, then that's going to be y is equal to 0.8. So that's going to be the coordinates over here. Do the same thing for x is equal to 2. You're going to get 1.6. Do the same thing for the rest. And these are going to be your values for your table of values. And all you simply need to do now is find, therefore, an appropriate scale for both along your x-axis as well as your y-axis, and then plot them. Now notice that in this case over here, I've decided to go with the same increment. So by going up by ones, moving from left to right. But along my y-axis, notice that I'm not going up by 1. I'm choosing to go up by 0.8, and that's up to you, okay? So in this case over here, by choosing at 0.8, obviously I'm therefore going to be able to draw a very nice straight line as such to show the motion of the butterfly. So now what we're going to do is now sketch the graph of the cat, which is represented by the equation y is equal to 4x minus 6.4. Let's find out both the x and y intercepts to actually sketch this. So to find out your x int, sub y is equal to 0, move the 6.4 by adding 6.4 to both sides, and then divide both sides by 4 to find your x intercepts. So therefore your x intercept is going to be at 1.6, 0. After finding the x-intercept, you can actually find your y-intercept value, and in this case, your y-intercept value is going to correspond to the value of c, which is going to be negative 6.4. But remember that I've said that I'm not showing you what the negative y values, since they have no significance at all. They don't actually represent anything at all for this particular scenario. Instead, I'm going to use another method for us to actually sketch this particular equation over here. So if you guys can recall from our previous lessons, okay, when we were talking about graphing, you can actually use the gradient in order to find the next coordinate that lies along the actual straight line, and therefore connect the dots between those two coordinates. So in this case over here, your gradient is equal to 4, okay, and that can be written as 4 over 1, since we know that gradient refers to rise over run. What this means is that for every unit you move to the right, while moving across 1 unit, you're going to be moving 4 units up. So I'll show you what this actually looks like. So as I said, we know that your x-intercept for this equation is equal to 1.6. So therefore that is 1.6 over here, which is represented by this red dot over here. I'm going to be moving 4 units up, and therefore 1 unit to the right, okay? And by doing so, therefore, this is going to be the next coordinate that lies along the straight line. And all I need to do now, in order for us to actually sketch this graph, is just essentially draw a line that cuts between these two dots over here. So this is the graph for the motion of the actual cat. Now I do want to add that if you are going to be using this particular method over here in order for you guys to actually sketch the motion of the cat, I strongly encourage you to actually show me what is the actual next coordinate if you're going to be using the gradient to find the next coordinate along the actual straight line, okay? Let's move on to the next question. So the next question wants you to find out how far does a cat run before it jumps for the butterfly. And in order for you to answer this question, you must really understand what your axes represent. Now notice over here, I just want to draw your attention that your y-axis represents the height in meters. So when y is equal to 0, that means you're still on the ground. You haven't actually left the ground yet. So any values above 0, that means you're actually in the air itself. So in this case over here, you're going to find essentially what is your x-intercept is going to be, because at the x-intercept, your y value is equal to 0, because at that point, the cat is still running and still on the floor. So since the y-axis represents the height above the ground or is in the air, the distance that the cat ran before it jumped will be equal to the x-intercept, which is what you've calculated earlier on. And for these types of questions, you actually need to provide an actual worded answer over here, okay? The next question wants us to find the point of intersection of the two lines that we've actually drawn, okay? And it also wants you to explain what does the point of intersection mean by using the actual scenario that's actually given to us. Now, in this particular question over here, it's not actually asking you to solve for the point of intersection algebraically, meaning using simultaneous equations. Instead, it's actually asking you to actually pinpoint what is the point of intersection by just eyeballing it, okay? So this question doesn't want you to find the point of intersection algebraically, as I said. Rather, it wants you to eyeball your point of intersection based on the sketches you've actually drawn. Remember that when we actually talk this in class, if you're going to be pinpointing what your point of intersection is just by visually inspecting it, this is not going to be a very accurate way, but it should be kind of close to the actual answer. So in this case over here, notice that your point of intersection is kind of just before 2 in terms of the x values, and it's just kind of underneath 1.6. So I'm going to say that my point of intersection is going to be roughly around 1.9, 1.5. So that is going to be my point of intersection. And as I said, it doesn't actually matter if this value is kind of slightly off from the legitimate answer, because this is an inaccurate method. So now I'm going to be explaining what does the point of intersection actually mean in this case. Well, in this case over here, remember that your x value refers to the horizontal distance in meters. So in this case, 1.9 meters refers to the total horizontal distance that the actual butterfly has moved from the actual ground or from the petal. Remember that the origin over here is where the butterfly was initially when it was on the nectar, when it was on the ground. So 1.9 meters is the total distance it has traveled horizontally, okay, after it has flew. And the second value of here, 1.5, what does that mean? Well, 1.5 meters in this case is I suppose the vertical height where both the cat as well as the butterfly is the same. So this is the pretty much the height where the cat catches the butterfly mid-air. So they're both going to be 1.5 meters above the ground. And this is how you should be answering the question over here. And now for this question over here, you're going to now prove to see whether your point of intersection that you kind of subjectively eyeballed is actually accurate. So in this case, y is equal to 0.8x, y is equal to 4x minus 6.4. So I'm going to be using the substitution method by equating both equations together. So this is what your equation should now look like. I'm going to move x to the left-hand side of the equation and then simplify, divide both sides by 3.2. You're going to get a nice whole number. Your x value is going to equal to 2. So we're going to sub x is equal to 2 into the easiest equation, which is y is equal to 0.8x. If you do this, then you're going to get a y value of 1.6. So therefore, this is going to be your point of intersection. Previously, I said that my point of intersection was 1.9 to 1.5. So this is kind of similar, but as I said earlier on, if you're going to be using the algebraic method, which is solving it using simultaneous equation, obviously this is going to be a lot more accurate. And for the very last question over here, which is probably the most difficult, the question reads, what if the cat ran twice as far before jumping? Would it be able to catch the butterfly? And you need to be able to discuss and pretty much go into a lot of detail in order for you to get full marks for this particular question over here. So in this case over here, because the cat is going to be running twice as fast, this implies that instead of running 1.6 meters, which it had to do initially, it's now going to be running 3.2 meters. And another thing that also changes as a result of that is because since the cat is now delaying its jump, that would mean that the butterfly would therefore be moving or flying a little bit higher above the ground. So therefore, this would indicate that your point of intersection is going to be different, where your y value is going to be slightly more higher. So let me show you how we would actually do this. So for this type of question over here, in order for you to answer it, you have to actually make an assumption. And in this assumption over here, you're going to make the assumption that the cat is going to maintain its exact same speed when it's running twice as far. So because it's maintaining the exact same speed, this also implies that the gradient will be the same. And we talked about previously that when the gradient is the same, that means that essentially you're going to have a parallel line. So a line that's parallel to this line over here, which is the equation for the cat, okay? So in this case, it's going to have the exact same gradient, which is going to be 4. So let's find an equation to model the new movement of the cat if it runs twice as far. So in this case, as I said, we already know what your x-intercept is going to be. Your x-intercept is going to be 3.2. So let's substitute that coordinate into the equation to solve for c. If you do this, then your c value is going to be equal to negative 12.8. So therefore, this is going to be your equation over here. I'm now going to be sketching the new equation to show you visually where the new point of intersection is going to lie. As I said over here, that your y-intercept value is going to equal to negative 12.8, and I'm not going to be showing you what that is since I've decided to only show the positive x and y values. So in order to actually show you what this graph looks like, I'm going to be using the gradient again to show the next coordinate that lies along this straight line. In this case, remember that your gradient is equal to 4, which is equal to rise over run. Okay, so therefore in this case, you're going to be rising 4 units up for every 1 unit you move to the right. So that's going to be reflected by these dashed lines over here. So this coordinate over here is going to therefore lie along this straight line for this particular equation. And all I need to do now is just draw a line that connects it. And as you can see, these two lines over here are now parallel to one another. So as you can see over here, now that I've drawn the line, you can clearly see that the point of intersection is going to be a bit more different. And I'm going to use simultaneous equations to solve accurately what the point of intersection is going to be. So therefore, using the substitution method, you're going to get a value that is equal to 4, 3.2. So in this case over here, you now need to answer the question, would it be able to catch the butterfly knot? And all you need to do is simply look at your point of intersection and specifically look at the y value. This means that the cat needs to actually jump up to a vertical distance of 3.2 meters in order for it to catch the butterfly. And I'm hoping that you guys should be able to recognize that most cats aren't able to actually jump that high at all. That's an unrealistic value. So this is how I'd answer the question. I've said, therefore, cat would need to be able to jump 3.2 meters to catch butterfly. However, this is an unrealistic value for a cat to be able to jump this high. Hence, it will unable to catch the butterfly if it ran twice the distance over here. So that's how you'd answer the final part of this question. You need to firstly find the equation of the new motion when it runs twice as far. You need to use simultaneous equations to find a new point of intersection. And lastly, you need to add the worded answer in order to get the full marks for this particular question over here. This is the end of today's video. Hopefully you guys find this informative. I'll see you again in the next video. Bye.